one topic that I want to start with is about sets of functions, because this is something that I have noticed a few times that people seem to be having trouble with. So let's do some examples. So there are a number of ways to make a new set from two sets that you have. You can do things like A intersect B, A union B, A cross B. Can I think of more than that? I guess A minus B. But one that comes up a lot is set of functions from A to B. And let me start by saying that this one is a little bit more abstract and a little bit harder to understand, because functions already are complicated things. And so taking a set whose elements are functions is kind of a complicated thing to do. So I want to start by writing down a very explicit example. So what does the set of functions from A to B look like? So let's say A has two elements and B also has two elements. Then let's just try to write it down. So this is some set. Let's just write down all the elements. And let's write them down in this diagrammatic form that we've been using. So this is A. This is 0 and 1. This is B, 0 and 1. And for example, if we have a function that sends 0 to 0 and 1 also to 0, we can draw it like that. So without keeping the labels on, let me draw all of the possible functions. All right, I think this is all of them. So there are a lot of questions you can ask about things like this. Let me go through a couple of things that have come up on questions on Piazza, for example, possibly in office hours as well. So the first thing to note is that being injective and surjective and bijective are some special conditions that happen sometimes, but not all the time. So if you have two sets with the same cardinality, as we have in this case, then you can conclude that there exists a bijection. For example, this one and this one. But it will not be unique, first of all, as you can see here. And it also does not mean that every function is a bijection. For example, this function is not a bijection. In fact, it is not anything. Not injective, nor surjective, and so, of course, not bijective. And similarly, this guy is none of them. So there's a couple things that I want this to illustrate. First of all, that there is one way to think about sets of functions, which is very concretely like this. So you can write down their elements, they are functions from A to B, and there are many different types of functions which have many different properties. But I also want to point out that this perspective of thinking about them explicitly starts to become very difficult once you get bigger sets than, for example, 2 or 3 elements. So it's helpful to also be able to think about these things abstractly. So let me say this is explicitly And abstractly, we want to be able to say things like, here's a very important way of thinking about functions. The power set of A is in bijection with the set of functions from A to the set 0, 1. And if you forget how this works, the bijection that I'm referring to is the subset S corresponds to the function f if they're related by f of A is 0 if A is an element of S, and 1 if A is not an element of S. So from this perspective, we're thinking less about writing down all the elements of the set, for example, and thinking more about being able to relate it to some other set in a natural way. So for example, when you're doing questions about cardinality, and you see a set of functions, you should try to think about comparing it to this kind of thing. So, let's do, okay, that was kind of a lot of discussion, but let's do an example, or an example problem. If A has cardinality n, and B has cardinality m, how many elements does the set of functions from A to B have? So first of all, maybe to link this to what we were just talking about, what perspective would it be more helpful to take? Should we try and think about this explicitly or abstractly? And it seems like we would have a better time thinking about this explicitly because these are finite sets and we're looking for some finite number of elements here. So if we're going to count things in a finite kind of way, then it will help to work with the explicit interpretation. So essentially this just comes down to understanding what a function is. So a function f a to b assigns, let's go all the way back to the definition, assigns an element of b to each element of a. So essentially, if we're going to count how many of these things there are, for each element of A, we have, well, the cardinality B, so M options. For where descendant under this map. And they're all independent. So the number of ways to write down a function is m times m, where this, the number of factors in this product, is the number of elements of A. So this is n. So this is m to the n. The number of functions from a set with n elements to a set with m elements is second cardinality to the first cardinality. So you can think of it like b to the a.